Today I'm going to do a short demo on this Red Hat Advanced Cluster Management for Kubernetes. This is one of the tools that provided by Red Hat to give you a single pane of glass to manage your multiple cluster in terms of life cycles, the cluster life cycle itself, as well as the securities and also the applications. So here you can see these are the four main capability of this advanced cluster management. So it gives you an end-to-end kind of visibility where you can see all the systems alerts, critical application metrics, the overall system health, right? So this is typically useful for people like the site reliability engineers as is because they need to manage multiple classes across different kind of data centers ranging from on-premise to private cloud all the way to public clouds like AWS, Azure, Google and others. You also can manage your cluster life cycles instance of create, update, scale and remove the clusters. You also get to manage the application life cycles, like for example create an applications based on your declarative deployment configurations and also the placement policies across different OpenShift classes, for example, regardless whether it's sitting in your on-prem data center bare metal or is on the Google Clouds. And last but not least is about bringing the consistencies of the security elements across all these classes under this single management console. So let's take a look on the overview here. So these screens give you the summary of all the clusters you have. In this demo, I have 3 clusters that is provisions in AWS, and I have 1 applications pre-deployed, total of 3 clusters, 1 type of Kubernetes deployments, and across 3 different regions, and in total there are 8 nodes, and there are 857 ports across these 3 clusters. You also give me a summary of whether my cluster is complies to the policy I've set, which is under the governance, which I'll go through later. It also tell you if there's any port that is failing within the 3 clusters and the healthiness of the clusters, and if there's any issue with my clusters. Okay, so if I want to see actually what is the fail port that is happening here and where is it, I can actually click on this to further drill down into it. So it brings me to the next screen where it shows this is the port that is having a problem, and the issue is the image pool back off, and it's reside in these local clusters at this namespace. So this is how one operators or the SRE can easily identify the failure of the resources across the multiple cluster in your environments using this tool. Apart from that, we also can click on this to do a search. So this search is very powerful that it actually search across all the cluster that is registered under here. So the moment I click on here, you can see some content essays actually pop up. So I can probably search the kind of maybe I want to do a search of the port. Okay, and plus the label where the app value is Quarkus port name. So I'm actually looking for a Kubernetes resource of pod that has this labeling app equals to Quarkus pod name. So immediately it lists down these 3 pods that I have across these H1 clusters that is currently running. I also have one in my local clusters that is running as well, and the third one is running in my H2 clusters. Okay, so that is how easy you can actually search out any kind of Kubernetes resources across all your Kubernetes clusters or OpenShift that you have registered inside this advanced cluster management. Okay, now let's move to the cluster lifecycle management. So here I can see more details about the cluster I have. Like for example, whether these clusters are ready to serve and what are the providers they are from, and what is the distribution versions of each of these clusters. So I have my local cluster that is actually running at OpenShift version 4.8.2, while my 2H cluster actually having the latest versions, which is 4.8.4. From here I actually can click this link to actually do an upgrade of this cluster if I want to. Right, I get to pick what are the new version available for me to upgrade. Okay, so here I have different kind of labelings to identify the clusters, and the last piece of information here is showing how many nodes this particular cluster has. For example, this local cluster is a big cluster that comes with 6 nodes, and for the edge is a single node cluster. Okay. Now let me show you how we can create a new clusters from this screen. By clicking this create cluster, so I'll choose to create a Red Hat OpenShift container platforms, and I'm going to choose AWS my cloud provider because this is the only credential I have here. So before you able to create a cluster, you need to supply the provider credential, right? For example, if it's the AWS, you need to supply the AWS keys, secret keys, those informations before you actually can start creating the OpenShift cluster, because these two actually talk to the AWS API to request for the VM instances and install the OpenShift on top of it. So next, so I'm going to give a name for this. Maybe I call it OpenShift 4. Maybe I'll do a production site number 2. Okay, so I'll choose the cluster set if I want to manage them in a group, right? But I want it to be a standalone. This is the base DNS for these new clusters. I can choose the release image, which is the OpenShift version actually. So I just go ahead and choose the latest versions. I'll put some additional labeling here. So env prod 2 maybe. Okay. Next, here I configure which regions I want to deploy my OpenShift clusters. So for those who are familiar with AWS, you can actually see the similar regions listed is same as the one you see in Amazon console. Okay, in this case, let's go ahead and choose US East 2, select the subzones. I want it to be across multiple subzones, so I'm going to choose 3 of them. and I get to choose the instance type. These are the EC2 instance type you can choose from. So I just leave it as the default one. Next, here is where you pick the options for your worker nodes. So similarly, I want it to be across 3 different sub-regions. Okay, 3 worker nodes, storage. Next. And these are the network configurations. I just leave it as default. Is there any Ansible job template I want to execute? No. So just leave it empty. So once you review all the informations are correct, you can actually go ahead and click the create buttons. So now what is running behind it is that this advanced cluster management will actually talk to the Amazon API using the AWS key, the secret key that you are supplied, and request for the EC2 instance you selected, and start installing the OpenShift cluster on top of this. So the whole process will take about 45 minutes to 1 hour. But you can see that is how easy we actually can create a new OpenShift clusters using this tool. Okay, so apart from creating the OpenShift cluster, what happens if you have existing clusters that you already install, right? So you actually can import the cluster from there and then key in the relevant information here. Then you will be able to manage that particular cluster from this console as well. Okay, so I've shown you how to create, also import the cluster. Of course, we also can do other things like detach cluster. That means I detach it from this console, and that console then won't be able to manage by this advanced cluster management, or I can destroy the cluster if I want to. Okay, you also can do hibernate the classes. Okay, for example, let's say this is not an important cluster that you have to run all the time. Maybe it's a testing environment, a testing clusters. So you actually can go ahead and hibernate this cluster so that you can save some resources costs, especially when you are running all this in the public clouds. Okay. Next, I'll move to the applications lifecycle management. This is similar to cluster lifecycle management, but instead of managing the cluster, you are managing your applications lifecycle. So similarly, you can create new applications across your clusters. You can update, you can delete the applications. Let's go ahead and try to create one applications. So here, let's give a name for these applications. In this demo, I'll be using something called book import. So I'll name the namespace same as the application name. And I need to define the deployment resources locations. So in this case, I have my deployment configurations, services, all these predefined in a Git repository. So I need to supply the URL of the Git. Choose the branch, and if there's a path, okay, you can choose the path. And the last one I want to configure is where should I deploy these applications. Okay, so here I have 3 different choices here. I can deploy based on the labeling of the cluster, or I can choose to deploy all the online cluster and also local clusters, or maybe I just want to deploy on my local cluster only. But in this demo, I'm going to deploy this into all my edge clusters. which is labeled as env h. The rest I'll leave it as default and go ahead and click on save. So it will redirecting me to the details page. So this is the application that I have created. You can see is at the stage of singing the applications, where you actually start to detect the clusters. So based on the labeling I put just now, we actually found that there are two classes which is matching to that labeling, env equals to h, and this lists down two clusters here, h1 and h2. Then it will start provisioning the route resources, the service resources, the deployments, and also the replica sets. So within a few minutes, I am able to deploy this book import application across two clusters based on the labeling. And it makes sure these two applications are deployed using the same versions. They are totally identical except for the URL and also the environment specific informations. So we can actually click on the route here. So we can find there are two route URL here. Okay, one is for the H1, the other one is for the H2. We can actually click here to validate the application is up and running. Same thing applies to the H2. So this is the topology view of the book import applications. So if we go back to the applications, you can see now I have two applications listed here. And I can easily do delete the application, that means undeploy them if I want to. The last one I want to show you is on this governance. So this gives you the capabilities of providing the consistency from the security perspective across all your classes, which are able to manage by this advanced cluster management. So here it gives us a summary view. So based on the categories, I have this identity management, data security, and also information integrity. So under this category, no violation found. That means all my three classes are fulfilling this. But for the data security, there is one cluster that is violating this policy. For the identity management, there are two. I also can view from the perspective of standards. So for standards, we have 80053 here, we have NIST here. So let's say you would like to enforce some standard like PCI DSS, for example. Again, similarly to the standards here, you can enforce that kind of PCI DSS standards across the cluster you have. Okay, let's go ahead and take a look what kind of policy we can create here. So with this creating policy, you give a name of that policy, right? Choose a namespace where you want this policy to be stored. So we can actually store at the default. And specifications will be the policies that you want to create. So here give you a list of different kind of policies, like for example certificate policies, which helps you to monitor the expiration of the certificates prior to maybe 30 days, for example. Then it will notify you, and you can go ahead and renew your certificates, right? So there are other policy, like for example you want to encrypt the data in the etcd, which is the the data store of the OpenShift classes, or maybe you want to limit the number of the cluster admins you can create within a classes. Okay, there are quite a few of the policy here you can choose. You also can bring your own policies, your own customized policy, or any open framework policy that you found from other place, and you actually can import into here. Okay. Then you choose the cluster that you want to enforce these policies. So in this case, it actually making use of the labeling again. So if you choose Cloud Amazons, you enforce this policy throughout the whole cluster that you have provisions using AWS. Or you want to go with env edge, which are all the edge servers, cluster IDs, the versions, the regions, etc. Here you choose the categories of these policies, so standards. So here out of box we have NIST, STCF, PCI, FISMA, HIPAA. So you can choose which policy, which standard should this policy type to, and what is the categories, and also its controls. Okay. And last we have these remediations options of inform versus enforce. Inform means when there's a cluster violating these policies, it actually will inform you, and then you will need to do some manual steps to remediate these violations, or you actually can enforce, right? So some of these enforcement can make use of like Ansible jobs to help you to remediate the violations. Okay, so once you have created all these things, you can click on the create, and then you will create the policies. So prior to this, I have pre-prepared 3 policies that has been deployed. Okay, the first one is I enforce the policy of all the cluster I selected under the labeling here must do the image scanning, must have the image scanning capabilities in the cluster. Okay, and the other one is this admin role, where I want to limit the so-called the super user of the cluster that I have inside all my cluster. I don't want to have too many super user for one clusters. And the last one is about the security, the expiration of the security certs. Okay, so that's how the policies can be enforced using these tools. Okay, and the last one here, the credentials. This was the cloud provider information I was talking about before you actually can create the classes. So here I actually pre-registered the credentials of AWS, where I have my DNS domain, the AWS access key, the secrets key, and also others security information that required for me to connect to the AWS to create a new classes, right? So that's all I want to show in this advanced cluster management demo. Thank you for watching.